Hi everyone, welcome back. This is another video in our computer vision and OpenCV playlist. My name is Ofyong Basi, and in today's video, we'll dive into thresholding, types of thresholding, real world cases of thresholding, and the practical aspect of thresholding. So what is thresholding? Thresholding is a technique that is used to binarize an image, meaning it converts a grayscale image into black and white based on a threshold. There are two types of thresholding: the simple thresholding and the adaptive thresholding. The simple thresholding is a fast and efficient thresholding technique that works well with high contrast images. How about the adaptive thresholding? The adaptive thresholding calculates a different threshold for each pixel based on its local neighborhood instead of applying the same threshold across the whole image like the simple thresholding does. The real world cases of thresholding are QR code detection, OCR, medical imaging like X-rays, and also fingerprints. These are different real-world cases of thresholding. Without further ado, let's jump into the code for the practical aspect. But hold on, if you found this useful, hit the like button, subscribe, and share. Okay, so what we need to do first is to work on this simple thresholding, of which we are going to create a new file called thresholding.py, and we'll import our cv2, and I'll say my image is equal to cv2.inread of what do we want to use. So I think I have an image here which I downloaded and it's called child. Okay, we want to threshold this child, so I'll say it's called child.jpg. And do not forget, before you threshold an image, you must convert it to grayscale. That is what threshold accepts. It accepts images as grayscale, so the image has to be grayscale. Say img_gray is equal to cv2 dot, and to convert, I already showed you in the color spaces in a previous video. You've not watched it, I recommend you go back and watch how we convert from one color space to another color space. So we'll convert this image to cv2 color from BGR to gray. So the channel we get from image ImRead is actually BGR, is BGR we get. So what I'm going to do is that now we've converted from the original image to gray, and well, let me just visualize so you'd see. So I'll say cv2.imshow. Let me visualize our image over here, and there's our image, and cv2.imshow also visualize our gray image and our gray image, and cv2.weight key of 0, and that's it. So let's just see our grayscale image, and let's see if we can actually read our image. Okay, so this is our grayscale image. Sorry about that. This is our grayscale image, and this is the original image. Now let's see how we can actually threshold this. So in order to threshold this, what we do, we say that ret and thresh is equal to cv2.threshold, and threshold over here accepts an image, and it actually accepts a value. And what would that value be? Let me say 80, and this is the threshold value. I also accept 255 as a maximum value. And what next do we need to do is the type of thresholding. I'll say cv2.thresh binary, and that's it. So let's visualize our threshold image, cv2.imshow, and that'll be thresh. Sorry about that. Thresh over here will be thresh, exactly. So let's visualize and see. So you can see, oh sorry, I made a mistake. I'm supposed to use the gray image. Like I told you, it has to be gray. So this is it. So this is our thresh. We don't even need this gray image. All I want you to focus on is this here, and this is. So this is how we actually threshold an image. And you might be wondering, why do we really need to threshold an image? Well, we need to threshold an image for segmentation. Segmentation is a major reason why we actually threshold our image. So I'll love you to play around with this value. This is maximum thresholding value, while this is the threshold value. So you could do 120. Let's see what we'll get. and that's it. So you see how it is. You see how it is. This is it, and this is it. Let me comment this gray. I don't need gray. I don't want it to show, and sorry about that. And this is it. So you could actually see this is how it looks. Now we'll be able to achieve the simple thresholding. Now I want us to further work on adaptive threshold. But before we work on adaptive threshold, I have another image here which is actually called report.jpg, and we want to see how we can threshold such that the background will be clean. It will actually segment. What I mean by segment, take away the text and make sure that the background is actually clean, and that's where segmentation comes in. So let's try and see how we can achieve that with the simple threshold, and also compare it with what we'll get from the adaptive threshold. From there we'll know which is better for which use case. So I'll say that it's called report.jpg, and let's see. This is still for simple threshold. So you see over here, the background is clean, but we still have noise here. We still have some dirt here. We have this black. We have all these things that doesn't make it look pleasant. So in order for us to achieve these and make sure that it's clean, we'll try to use adaptive threshold. So you could see that adaptive threshold really works well with OCR application. That's optical character recognition. So in order for you to actually work on OCR, you need to have a good threshold image. So what I'm going to do is that I'll say adapt underscore threshold .py. So I do not need to write all that again. To make it shorter and not too long for you, I'm going to copy and reuse this code. So what I'm basically going to do is, this is what we want to change, and I'll say that my thresh is equal to cv2.adaptive threshold. Exactly. So this is the adaptive threshold, and what we need to do is to pass in the gray image over here, and the next thing we need to do is to pass the value here, and the value you are going to pass is the maximum value, which is 255, and we'll pass the cv2.adaptive Gaussian, adaptive thresh Gaussian. That's what we're going to pass, and the next parameter we'll need is the cv2 the thresh binary, and we are going to pass an odd number here, 21, and here you can put in any value here which will actually be used to threshold this, and this is also called constant. So let's see how we can threshold this, and before then let me just use the other image, which was, no, let's stick to reports because our aim is to actually see how we can achieve that report. So you see, this is how it is. It looks good, right? The background has been cleaned off and it looks absolutely nice. So this is what you can do with thresholding. You can explore more. Let me see how we can change this to 10 and see what we get, and look at it. 10 still gives us a dirty background and not really nice. So you could make it 30, you could make it 35, as the case may be. So that's it, and that's it. So that's all. I'm really excited that you've been able to complete this thresholding video. I would recommend you to practice it again and again to solidify your knowledge. Meanwhile, in our next video, we'll dive into edge detection. If you found this useful, hit the like button, subscribe, and share. See you in the next video.